Hello and welcome to the Sleepy Scientist Stories. I'm so glad you found your way here. Whether you're lying comfortably in bed, resting on the couch, or simply letting your thoughts drift softly as sleep approaches, this space is made just for you. Tonight, we'll be taking a gentle journey into something quietly mysterious, deeply beautiful and hidden. Beneath the surface of everyday life, the 125-year-old physics problem explained a story of how a simple question about light led to a discovery that quietly reshaped our understanding of reality. Now, I should mention, I've done my best to make this video as calming and peaceful as possible, but there's always a small chance it might be just a bit too interesting. If it happens to keep your mind awake, well, at least you'll drift off a little wiser. If you're already enjoying this quiet moment, I'd be truly grateful if you gave this video a soft like and perhaps even subscribed for more cozy science journeys like this. It really helps sleepy minds like yours find their way here. And if you feel like sharing, let me know down in the comments where you're listening from and what time it is there. I always love watching this little constellation of bedtime light up around the world. As always, this video is made purely for relaxation, comfort, and educational curiosity. It is not intended as medical advice or a replacement for sleep therapy. Tonight, we begin not with answers but with a question, a problem, quietly lingering in the fabric of the universe for more than a century, waiting patiently for curious minds to notice. There is something quietly comforting about the way the universe surrounds you. A vast dark ocean stretched far beyond your sight, sprinkled with the soft glow of distant stars, as if tiny lanterns had been scattered across an endless velvet sky. And as you lie here breathing slowly, with the weight of your body sinking into the surface beneath you, the universe feels close, not distant, as though it is leaning in, offering a gentle whisper, a quiet story waiting to be told. Tonight, you are not rushing toward answers. You are simply drifting into the edges of a mystery, a puzzle that hums softly beneath the fabric of reality, a puzzle that has lingered for more than 100 years, patiently waiting for curious minds to notice. It is the kind of problem that hides in plain sight, so simple in its appearance, yet so quietly stubborn that the greatest thinkers of a generation once stared at it in frustration, unable to make it fit within the tidy boxes of what they thought they knew. The story begins not with the grand vastness of galaxies or the collapse of stars, but with something much more humble, something close, something familiar to every corner of your life. It begins with light, the gentle glow of warmth, the shimmer of a flame, the radiance of the sun. When scientists of the late 19th century studied the way objects glow when heated, they noticed something strange, something that didn't quite make sense. When metal is heated, it glows first red, then orange, then white, then blue. You've seen this before in the ember of a fire or the coils of an old electric stove. It seems simple, it seems predictable, but when the scientists tried to describe this glow mathematically, the equations fell apart. The numbers behaved as if the universe itself had gone mad. According to the best physics of the time, the amount of energy radiated at higher frequencies, like ultraviolet light, should increase without limit. It suggested that objects should release an infinite amount of energy at these frequencies, which of course they do not. The real world does not explode in waves of invisible fire every time something heats up. This was called the ultraviolet catastrophe, a name both dramatic and oddly poetic. It was not a catastrophe for the world itself, but for the models, the neat mathematical frameworks that scientists had so carefully built over centuries. The universe, it seemed, was quietly refusing to cooperate. Nature was whispering something subtle, truth just out of reach, the kind of truth that floats at the edge of thought, like the memory of a dream, slipping away before you can fully hold it. And so the puzzle lingered, like a question half formed. Why didn't the models work? Why didn't the light behave as it was supposed to? This was not some fringe curiosity. It was a fundamental hole right at the heart of physics. It touched on the very rules that governed how heat turns into light, how energy moves, how the smallest pieces of reality interact quietly beneath everything you touch, everything you see, everything you breathe. This puzzle waited patiently. The scientists of the time were people of precision, of logic. They had built a world out of certainty with clocks and levers and gears, a universe that ticked forward like a grand mechanical watch. But now that watch was stalling, caught on something. It couldn't explain something hidden in the glow of heated matter, something softly whispering from the heart of reality. The solution was nowhere in sight. Not yet, but the question had been noticed, fully noticed. And that noticing was the beginning of something much larger. Tonight, as you lie there breathing slowly, you are stepping into that story, not as an outsider, but as someone moving gently along the same path that those thinkers once walked. Your mind, drifting through the same wonder, the same quiet confusion, you begin to imagine the room where it first happened, a quiet laboratory, somewhere in the twilight of the 1800s. The air smells faintly of oil lamps and metal tools. There are polished brass instruments, papers neatly arranged, inkstains on fingertips, and someone sits at a desk, looking not outward into space, but inward into the strange behavior of something simple, a glow, the warmth of heated matter. Something that should be easily understood, but stubbornly is not. You can almost hear the faint scratching of a pen, the ticking of a clock, the silence between thoughts, as if the universe itself is waiting, holding its breath, because something is about to change, not in a loud sudden burst, but like the slow turning of a page. A shift subtle and profound, a whisper becoming a voice. The ultraviolet catastrophe was more than a mathematical failure. It was a signal, a doorway, a hint that the world was not what it seemed. And as you float gently through this moment, you begin to feel it to the edges of certainty, softening the realization that the universe is both knowable and mysterious, both close and unknowable. The glow of a heated object becomes more than light. It becomes a clue, a question wrapped in radiance, waiting for someone brave enough to ask why. Why does this happen? Why does the math fail? What secret is hiding inside the glow? As your thoughts drift like soft clouds carried on a gentle wind, you realize that every great discovery begins like this. You drift gently now through the folds of time, back to a world that feels quieter, slower, simpler, a world where gas lamps flicker on cobbled streets, where the ticking of pocket watches marks the rhythm of busy lives, and where the minds of scientists believe they are on the very edge of knowing everything. As you float unseen through the lecture halls and smoky laboratories of the late 1800s, you sense a peculiar kind of confidence in the air, a belief that nature is almost fully solved. The great clockwork of the universe seems neatly wound and understood, from the swing of a pendulum to the orbit of planets, to the pull of tides. All fits comfortably into equations, tidy and precise. Yet beneath this illusion of completeness, something waits, something subtle and restless, a gentle trembling at the seams of certainty. It begins with something deceptively simple, the glow of heat. You have seen it yourself countless times, the way iron blushes red when kissed by fire, the way a stove coil glows orange, then white as it burns hotter to the eyes of the time. This glow was not just a curiosity, it was a window into the deep workings of nature, how matter holds energy, how heat transforms into light. The scientists believed the answers lay close within reach, guided by the laws of classical physics, by the elegant mathematics of men like Newton and Maxwell. And yet the closer they looked, the more the glow of heated light began to misbehave, to slip through the fingers of expectation. They set about describing it mathematically, imagining an idealized object called a black body, something that absorbs and emits all radiation perfectly, a theoretical tool, simple in concept but powerful in application. Through this, they hoped to describe how light emerges from matter across different temperatures and colors. But when the numbers were crunched, the equations began to spiral into absurdity. The energy predictions at low frequencies matched reality quite well. But as the frequency climbed toward the ultraviolet, the equations unraveled. The predicted energy surged toward infinity, suggesting that even the most ordinary object should emit an impossible flood of high-frequency radiation, an invisible fire that does not and cannot exist. The math said the world should glow with deadly ultraviolet light, yet clearly it does not. Nature refuses this absurdity with effortless grace. This paradox was quietly devastating, known as the ultraviolet catastrophe. It stood as a blemish on the beautiful fabric of classical physics, a subtle whisper that somewhere in the foundations something fundamental was wrong. As you drift through this moment, you feel the confusion of the physicists, as if standing among their cluttered desks filled with scribbled pages, ink-stained hands, adjusting brass instruments. They check their numbers again and again, but the universe refuses to obey. They try patching the formulas, applying corrections here, adding adjustments. They're hoping to tame the wild predictions, but the flaw persists, stubborn and unmoved, like a knot in the fabric of reality that refuses to untangle. It was not just a mathematical inconvenience, it was a riddle about how nature truly behaves. It asked a deeper question, one that trembled softly beneath the surface. Is reality truly smooth and continuous? Or is there something more, something hidden that flickers beneath the surface like grains in a beam of light? This question hovered unspoken, in the minds of many, though not all, were ready to confront it. After all, the notion that energy might not be infinitely divisible felt alien, uncomfortable, like standing on the edge of a cliff, looking down into a landscape not yet mapped. And yet, the glow of heated objects continued to quietly rebel against the neat expectations. The longer they studied, the clearer it became. The old rules could not explain this. The universe was signaling something quietly profound, that the old picture of reality as a smooth, predictable continuum was incomplete, like a painting missing half its colors, but invisible to the eye. You feel the weight of that realization resting gently in the minds of those thinkers, the creeping awareness that an answer might require breaking from the comfortable traditions of centuries, as if the universe was offering a gentle invitation to step beyond the familiar, to listen more closely to the quiet whispers of nature herself, not in thunderous revelation, but in the soft, persistent glow of things warming in the dark. And even as frustration brewed among some, a quiet sense of wonder began to awaken among others. For perhaps, if nature refused to follow the rules, it was not because the universe was broken, but because the rules themselves were only part of the story, a fragment of something deeper, something waiting just beyond the edge of understanding. And as you continue drifting softly within this moment of confusion and discovery, your thoughts begin to follow the thread of a name, a quiet figure sitting in his study, quietly thinking, sketching ideas that even he does not yet realize will change the world, a figure whose cautious boldness will soon offer a key to this stubborn problem, someone who is about to suggest something radical, that energy does not flow like water, but comes in small, discrete steps, like grains of sand, a thought so strange yet so necessary that it will mark the beginning of an entirely new way of seeing reality. And as this thought hangs softly in the air, you feel the quiet pull toward the next chapter, a moment where the problem meets its first whisper of an answer in the hands of a man named Max Planck. You find yourself now gently floating deeper into the very heart of the puzzle, as though the universe itself has opened a quiet doorway into one of its most subtle mysteries, a mystery that does not shout but hums softly just beneath the surface, waiting for curious minds to notice. It begins with something simple, something familiar, the gentle glow of heat. You have seen it countless times. The warmth of a candle, the orange blush of iron as it heats the soft shimmer of the setting sun. Yet, behind this familiar glow hides a question so stubborn, so quietly perplexing, that it will force the entire field of physics to bend in ways no one yet imagines. Here, you hover near the idea of what scientists call blackbody radiation, a strange name for something that touches nearly everything in existence. Imagine for a moment an object that absorbs all light that touches it, every color, every wavelength, without reflecting anything back. This is a black body, perfectly dark when cold, but glowing beautifully when warmed. And when it glows, it does so not with a single color, but with a smooth blend that shifts as it gets hotter. First a dim red, then brighter orange, then white, and eventually blue. The color of heat itself shifts with temperature. It feels natural, intuitive. But when the scientists of the late 19th century attempted to describe this glowing mathematically, their numbers rebelled. The early equations predicted that, as the frequency of light increased, especially toward the ultraviolet end of the spectrum, the amount of energy emitted should also increase without limit. The math said it should rise infinitely, exploding into absurdity, suggesting that a simple warm object, like a glowing ember or a heated stone, should release an impossible torrent of ultraviolet light, a flood of invisible energy, so intense it would burn the world to ash. And yet the universe does no such thing. Reality itself calmly refuses this prediction. It is as if nature looks at the flawed mathematics and simply smiles, shaking her head softly, whispering, "No, not like that." The equations were not wrong in every sense. They worked beautifully at low frequencies, explaining the red and orange hues of cooler objects. But as the frequencies climbed toward violet and beyond, the math shattered like fragile glass dropped onto stone. This profound failure became known as the ultraviolet catastrophe, not a catastrophe for nature, but for the confidence of physicists whose tidy models could no longer hold the truth unfolding before them. You drift now beside them, standing quietly in the dusty glow of their labs, watching their hands scribble equations on chalkboards, trying again and again to wrestle sense from nonsense. Their minds are brilliant, sharp, disciplined, yet the more they try to patch the equations, the more the numbers laugh back, defiant and wild. The failure was not just mathematical, it was philosophical, a challenge to the very belief that reality could be perfectly understood through smooth continuous functions, that energy flowed like a gentle stream, endlessly divisible, infinitely fine, but the glowing black body whispered a different truth, that perhaps nature does not divide itself endlessly. Perhaps there are steps, tiny grains hidden within the smooth surface of things, like the gentle texture of sand beneath a calm ocean. This idea, though not yet fully formed, hovered like a ghost at the edges of thought. The scientists of this time felt it, even if they could not yet name it, a subtle pressure building, a whisper that the universe was asking them to let go of old comforts, of old assumptions, and step into something entirely new. But what could that something be? Was energy truly quantized, broken into tiny pieces instead of flowing smoothly? Was the light itself hiding some deeper secret? You float with these questions now, feeling their weight, not as burdens but as invitations to wonder, to imagine, to consider that the world is always more mysterious than we assume. And as you linger here in this moment of confusion and possibility, a name begins to form gently in your mind, not yet a solution, but the quiet approach of someone who is about to change everything, someone who even now sits quietly, unaware that he is standing at the edge of a revolution. Max Planck. Now you find yourself drifting quietly toward the quiet figure of Max Planck, a man not drawn to wild theories or revolutionary thinking, but rather someone deeply devoted to order, certainty, and the elegance of classical physics. You float gently in the soft lamplight of his study, where shelves are lined with thick books, papers neatly stacked, and a clock ticks softly, marking the steady rhythm of thought. Planck is a man of discipline, a man who trusts in the continuity of nature, in the belief that reality behaves smoothly, predictably, like the gentle slope of a hill or the graceful curve of a wave. Yet here he sits, brow furrowed, pen resting still for a moment in his hand, staring at the numbers that refuse to make sense. The ultraviolet catastrophe continues to haunt him, this strange misbehavior of heated light, this quiet rebellion of nature against the rules that so many brilliant minds have written. He does not wish to rewrite the laws of physics, but the whisper of the problem grows louder, refusing to fade, and so, almost reluctantly, Planck begins to look for a mathematical trick, not a theory, not a worldview. Change, just a tool, something to make the equations fit, to tame the wild predictions of infinite energy. He begins by imagining something strange. What if energy is not endlessly divisible? What if instead it comes in tiny packets, discrete steps that cannot be broken down further? He does not yet believe this is how nature truly works, but as a mathematical convenience, as a bridge to cross this troubling gap. He tries it anyway, assigning to each frequency of light a minimum amount of energy, a little packet, a quantum, and with this simple but radical adjustment, the equations settle, they breathe, they behave. The infinite collapse into ultraviolet madness disappears, replaced by a curve that mirrors the real world perfectly. The match between theory and observation is almost eerie, almost too precise to be an accident. Planck sits back quietly, staring at the simplicity of it, and yet the discomfort grows. What has he done? This is not the universe as he understands it. Energy is supposed to flow smoothly, like water, like wind, not jump in steps like the ticking hands of a clock. But the numbers do not lie. The solution fits the data perfectly, more perfectly than any patchwork attempts that came before. You float here, watching the slow transformation unfolding, not in a burst of triumph, but in quiet tension, as Planck wrestles with his own disbelief. Caught between the comfort of the old world and the whisper of something entirely new, he publishes the result cautiously, presenting it not as a radical shift, but as a curious mathematical solution to a troubling problem. Yet beneath his caution, something profound has begun to stir, the idea that energy is quantized, that nature at its deepest level does not behave like a smooth canvas, but like a mosaic, built of countless tiny pieces. Planck does not yet see the full consequence of this thought. To him it feels like a necessary compromise, not a discovery of truth, but like a soft seed planted in the soil of physics. The idea waits, quietly ready to grow into something vast, something that will one day rewrite how we understand the universe. And as you float beside this moment, feeling the gentle weight of change beginning to unfold, you sense the stirrings of others' minds as well, minds that will soon take this quiet revolution and carry it further, minds that will ask if light itself behaves as particles, if matter too might shimmer between wave and particle, if the very fabric of reality is woven not from certainty but from probabilities, from mysteries, from things that are both true and not true, until observed and as This soft realization lingers. You begin to drift toward the next voice in this unfolding story, someone who will soon take Planck's reluctant step and turn it into a bold stride, someone whose name will echo through the very nature of light itself. A name whispered now at the edges of your thoughts, Albert Einstein. You drift now into a world that feels quietly unfamiliar, yet softly mesmerizing, a world where the smooth, comforting fabric of reality begins to shimmer as though seen through rippling waterlines, once thought clean and clear, dissolve into something grainy, textured, mysterious. You are floating in the gentle twilight between certainty and possibility, where the universe no longer whispers in absolutes, but instead hums softly in the language of probabilities. The idea that began with reluctant leap now begins to unfold, to bloom into something larger, something more unsettling, and yet quietly beautiful. Energy, it seems, does not flow like a smooth stream, but arrives in tiny discrete packets, each one a quantum, a little grain of energy, indivisible, fundamental. And now, as you listen carefully, you begin to notice that this graininess extends beyond heat, beyond light, beyond the gentle glow of black bodies. It reaches into the very heart of existence itself. Imagine for a moment that light, which once seemed like a smooth wave dancing endlessly through space, now also behaves like a particle, a tiny packet of energy, called a photon, not a continuous flow, but a flickering arrival of energy in steps, discrete, precise. You drift gently now through the thoughts of Albert Einstein, a young man quietly contemplating the nature of light, a mind ready to step beyond the comfort of classical thinking. Einstein proposes that light itself is not merely a wave as Maxwell's equations suggest, but also a particle, a quantum of light, capable of delivering energy in perfectly measured packets. This bold idea explains the photoelectric effect, a strange phenomenon where light striking metal releases electrons, but only if the light's frequency is high enough. No matter how bright the low-frequency light is, it cannot dislodge an electron, but a single photon of high enough frequency can. Einstein's realization confirms something quietly radical, that energy transfer itself is quantized, bound by the grainy structure of the quantum world, and as this bond deepens, so too does the mystery. Because if light behaves this way, then what of matter itself? Does the graininess stop with energy, or does it extend into the very stuff of atoms, into the particles that make up you, your hands, your breath, your thoughts? You float now through the quiet investigations of other minds, young physicists peering into the invisible realms of atoms, wondering if the rules of the quantum apply not just to energy but to matter itself. And as you glide through the gentle fog of curiosity, you begin to feel the strange duality at the heart of this unfolding mystery. Matter sometimes behaves like a solid particle, a tiny speck, moving through space, and yet it also behaves like a wave, spreading out, soft, uncertain, not pinned to any one place, but shimmering through probabilities. This is the birth of wave-particle duality, a quiet yet profound truth that the universe does not ask whether something is a wave or a particle, but answers softly yes to both, depending only on how you choose to observe it. And yet even that word observe carries a weight, a subtle power, because in this quantum world, to observe is not simply to watch, it is to participate, to influence, to collapse the fuzzy cloud of possibilities into a single reality. The universe, it seems, does not reveal itself fully until it is asked, and even then it answers not in certainty but in gentle weighted chances, probabilities unfolding like the soft roll of cosmic dice. You find yourself drifting now between these possibilities, feeling the soft rhythm of uncertainty, the pulse of a universe that no longer promises precision but instead offers patterns of likelihood, graceful clouds of potential where once there were points and paths and certainties. This is not the universe of Newton, not the grand clockwork of gears and springs, but something softer, stranger, more alive in its unpredictability. And yet, within this strangeness there is a deep elegance, a quiet beauty, for in the graininess of quantum the universe becomes not less but more rich, textured, layered, like a painting whose details change depending on how you choose to look. And as you breathe slowly, letting this idea settle into your thoughts, you begin to sense that the mystery deepens further. For if energy behaves like particles, and particles behave like waves, then what rules guide this strange new reality? What are the boundaries of knowing, and what happens when you try to measure this world with too fine a gaze? What slips away as you reach for certainty? And so with this question softly echoing in your mind, you find yourself gently floating toward the next chapter, where uncertainty itself becomes not just an inconvenience, but a fundamental truth, a principle woven into the very fabric of existence, a place where the more you know one thing, the less you can know another, where nature itself holds secrets, not out of cruelty, but as an invitation to wonder. You drift softly now, toward the gentle hum of another mind, a young man sitting quietly with a notebook open, his thoughts swirling like soft clouds of curiosity. This is Albert Einstein, not yet the famous figure with wild hair and world fame, but a quiet thinker and examiner at a patent office, someone who spends his days reviewing the inventions of others, while his mind quietly drifts far beyond the walls of that small room, beyond machines and diagrams, into the very fabric of reality itself. You float beside him now, feeling the weight of his questions, gentle but persistent, as he considers the strange new rule that Max Planck proposed, that energy itself does not flow smoothly, but arrives in tiny discrete packets, quanta. The idea lingers in Einstein's thoughts, not as a curiosity, but as something more, something whispering that perhaps the greatness Planck applied to solve one specific problem might not be just a mathematical trick, but a glimpse into how nature truly behaves. His gaze turns toward light itself, the most familiar yet most mysterious of all phenomena. For centuries, light was understood as a wave, a shimmering ripple through the electromagnetic field, elegant, predictable, smooth. But as Einstein contemplates the photoelectric effect, a puzzling phenomenon that refuses to obey wave theory alone, a new idea quietly begins to take form in his mind. He imagines a beam of light, not as an endless wave but as a stream of tiny packets, each carrying a discrete amount of energy. Photons, he calls them, little quanta of light, particles of energy themselves, no longer just a metaphor but a reality. That light behaves not only as a wave, but as a particle, depending on how you choose to look. This radical thought explains the photoelectric effect perfectly. When light of a certain frequency shines on a metal surface, electrons are ejected, but only if the frequency is high enough. No matter how intense a low-frequency light is, it cannot free an electron, but a single photon with enough energy can. It is not the brightness that matters, but the frequency, the energy per photon. As you float here beside Einstein's unfolding realization, you can feel the quiet beauty in it, the way the pieces click softly into place, a puzzle long unsolved now yielding to a gentle yet profound shift in perspective. Light is not merely a wave, it is also a particle, a dual nature hidden until now beneath the comforting assumptions of classical physics. Another crack forms in the old world, the smooth certainty of the past beginning to shimmer into something more mysterious, more textured. The universe now appears less like a grand smooth ocean, and more like a field of gentle rain, each drop a photon, each ripple a wave. Both descriptions true, depending on how you look, and yet this understanding does not bring confusion but a deepened sense of wonder, a realization that the world is not less orderly, but more subtly beautiful. Einstein publishes his idea, cautiously yet boldly, knowing that it will unsettle many, but the experimental results are undeniable. The photoelectric effect behaves exactly as if light were made of particles. This idea will eventually earn him the Nobel Prize, not for relativity, as many might assume, but for this very work, this quiet bridge between the world of waves and the world of particles. You drift now through the echoes of this transformation, feeling how the world of physics begins to shift softly beneath your feet. The certainty of classical physics gently dissolving into a landscape where duality reigns, where things can be both this and that, wave and particle, presence and probability, a universe where the lines are no longer sharp but softly blurred. Yet, even as this revelation settles, a deeper question begins to emerge. If light behaves this way, if energy itself is quantized, what about matter? Does this grainy duality extend beyond light into the very particles of atoms themselves? Do electrons, protons, even entire molecules follow the same strange dance between waves and particles? The answer waits quietly, just beyond the horizon of this thought, like the soft glow of dawn, hinting at a world about to be revealed. And as you breathe slowly, letting this idea drift deeper into your mind, you begin to feel the pull toward that next question, that next gentle unraveling, where the universe becomes not just particle or wave, but a tapestry of probabilities, a place where certainty fades into patterns of chance, where the rules of knowing themselves begin to shift, and where the dance of the quantum truly begins. You drift now into a realm where the ground beneath your thoughts begins to soften, where the neat boundaries of classical physics dissolve into something far more mysterious and delicate here. The universe reveals itself, not as a clockwork of certainties, but as a shimmering tapestry of possibilities. A place where particles no longer sit quietly in fixed locations, but instead hum with the soft rhythm of probability. A place where the simple question, "Where is it?" becomes not a statement, a fact, but a cloud of maybes gently hovering in space. You imagine an electron, not as a marble spinning around the nucleus of an atom, but as a soft blur, a wave of potential, a presence that is both here and there, and sometimes nowhere in particular. This is the strange and beautiful heart of quantum mechanics, a theory born not from a desire to abandon the old, but from the quiet necessity of describing what could no longer be ignored. The experiments had spoken the math, insisted reality itself, whispered in every observation that the world, at its smallest scales, does not behave like tiny billiard balls, bouncing predictably through space, but like something softer, something stranger. You float now alongside the minds who first dared to listen. Niels Bohr, Werner Heisenberg, Erwin Schrödinger, each one adding a thread to this unfolding fabric. Bohr envisions electrons existing not in smooth orbits, but in quantized energy levels, stepping between them in sudden quiet jumps. Heisenberg soon realizes that there is a limit to how much can be known at once. The more precisely you know the position of a particle, the less you can know about its momentum, and vice versa. It is not a flaw of measurement, but a feature of reality itself. Nature, it seems, gently guards her secrets not out of cruelty, but as an intrinsic truth, woven into the very structure of existence. Schrödinger imagines a different way to see it, envisioning particles as waves, waves of probability that spread out through space until observed collapsing gently into one possibility among many, and many. In this quantum world, the act of observation becomes something far more intimate, far more profound than anyone had ever imagined before. To observe is not simply to witness, but to participate, to influence, to coax reality from its swirling sea of potential into a single unfolding moment. You float deeper now into the mysteries of superposition, where particles can exist in multiple states at once, until the universe gently chooses and you begin to sense the quiet hum of entanglement, where two particles separated by vast distances remain mysteriously connected, so that what happens to one affects the other instantly, as if the universe itself holds them together with threads unseen. It is a place where cause and effect blur, where the universe does not merely allow for uncertainty, but is built from it. And yet, within this randomness, within this gentle blur, there is order, a different kind of order, a harmony that dances not in straight lines, but in probabilities, in patterns that emerge only when viewed through the right lens. Quantum mechanics does not destroy the idea of predictability, it reshapes it. It tells you that while you may never know exactly where something is, or exactly how fast it is moving, you can know the shape of its possibilities, the elegant curve of what might be. As you breathe deeply, letting this realization settle, you begin to feel how the world at large still holds its form, how the table, the ground, the stars remain seemingly solid, stable, certain. Not because the quantum rules vanish, but because when countless probabilities are layered together, the blur becomes sharp, the uncertain becomes the predictable, the randomness of the very small averages into the order of the very large. But here, in this quiet moment, you are floating not in the familiar certainty of the macroscopic, but in the delicate unfolding of the quantum, the place where existence itself hums softly with uncertainty, where reality does not exist until it is observed, or perhaps more accurately, where reality is always a symphony of potential, only occasionally collapsing into the notes you can hear, see, and touch. And as this gentle wonder fills your thoughts, you begin to drift toward the next whisper of curiosity, toward a realization that even the act of knowing itself has limits, that the universe softly insists there are boundaries to how deeply you can peer into her mysteries, and that the more you grasp at one truth, the more another slips softly beyond reach, waiting patiently in the shadows of uncertainty. You float now into the quiet mind of Werner Heisenberg, a young physicist sitting near a window where soft morning light spills over pages of scribbled equations. His thoughts are wrapped around something subtle, something quietly unsettling, something that refuses to be pinned down, and as you breathe in this space beside him, you begin to sense the tension between knowing and not knowing, the realization that Uncertainty is not just a flaw in tools or techniques, but something deeply woven into the very fabric of existence itself. Until now, it was possible to imagine the universe as something measurable, something that with enough precision and care could be fully understood, as though the position and momentum of every particle could be written neatly into the margins of reality. But the quantum world whispers otherwise as Heisenberg watches electrons shimmer in and out of definable places. He begins to understand that the more precisely you try to know where something is, the less you can know how fast it is moving, and the more clearly you try to know how fast it moves, the more its location slips softly out of focus. It is not a failure of observation, it is a feature of the universe, a gentle veil that drapes itself over the tiniest parts of reality. Imagine holding a soft glowing marble in your hands, and as you try to examine its exact position, it begins to blur its edges, fading, spreading into a gentle cloud. The sharper your focus on one aspect, the softer the other becomes. This is the uncertainty principle, a quiet law of nature that tells you the universe does not like to be stared at too closely. It prefers instead to reveal itself in whispers, in approximations, in patterns of probability rather than in absolute certainties. And as you float deeper into this idea, you realize how beautiful it is, how comforting it feels that nature guards her secrets not out of stubbornness, but perhaps out of kindness, a gentle reminder that the world is not something to be conquered by knowing, but something to be experienced, to be held lightly in wonder and curiosity. Heisenberg's realization does not come with a sudden flash, but with a slow unfolding, a recognition that the very act of trying to know shapes what can be known, that in the quantum world the observer and the observed are forever entangled in a delicate dance. And it is this dance, this impossibility of perfect precision, that gives rise to the strange softness of the microscopic world. Electrons do not orbit like tiny planets, they shimmer in clouds of possibility, existing here and there, until the act of observation nudges them into place. You feel now the gentle tension of this truth, the way it ripples out from the smallest scales into the larger world. And though in the world of the everyday, uncertainty is smoothed over by numbers too large to count, by atoms too numerous to notice, it is always there, humming softly in the background, a quiet blur beneath the apparent solidity of things, a gentle fuzziness at the edges of certainty. Heisenberg's principle becomes not just a rule about measurement, but a window into a deeper truth, that reality itself is a mosaic of probabilities, stitched together by the act of looking, by the presence of awareness. And as you drift gently through this realization, you begin to sense that this soft veil of uncertainty is not the end of the mystery, but perhaps only the beginning, a doorway into even deeper questions about the nature of observation, of reality, of existence itself. And so you find yourself softly drifting toward that next unfolding, where the strange rules of quantum begin to be seen, not just as curiosities of the small, but as the foundation upon which everything rests, waiting quietly for the next layer of the story to reveal itself. You drift gently now back toward where this journey quietly began, the soft glow of heated objects, the strange refusal of nature to fit inside the neat boxes of classical physics, the puzzle that for more than a century lingered like a whisper, waiting for someone to listen closer. And now, as you float through this unfolding moment, the pieces begin to settle into place, no longer forced, no longer made to fit a picture that was never quite complete. The ultraviolet catastrophe, the paradox, that once made equations explode into impossible infinities, now fades quietly, like mist beneath the rising sun, because with the arrival of quantum thinking, with the strange acceptance that energy comes in discrete packets, that particles shimmer between waves and points, that certainty itself is a softened thing, the problem gently dissolves. The old equations once demanded that energy spread endlessly across higher and higher frequencies, leading to absurd predictions, but now with quanta applied with Einstein's photons, understood with Heisenberg's uncertainty, embraced the math, aligns gracefully with what nature shows when an object glows, when it radiates warmth and light. It does so not as a smooth continuous wave, but as a gentle cascade of quantum steps, each frequency assigned its own packet, its own little grain of energy. And with this graininess, the runaway infinities vanish, replaced by curves that match perfectly the real world. You float now in this realization, feeling how the birth of quantum physics is not just the fixing of a flaw, but the revealing of an entirely new way of understanding reality. The smooth clockwork universe of Newton crumbles softly, not violently, but with a kind of graceful surrender. giving way to a universe that is richer, softer, stranger, yet more true. The tiniest parts of existence are no longer imagined as tiny marbles or precise gears, but as clouds of probability, as patterns of chance woven together by the simple act of existing. The glow of heated objects, the puzzle that once seemed so stubborn, becomes instead a doorway, a gentle invitation into this new world. And as the scientists of the early 20th century accept this new language of quanta, they begin to realize that it is not limited to blackbody radiation or the photoelectric effect. It stretches outward into the structure of atoms, into the binding of molecules, into the very way matter holds itself together. The simple fact that you are here, breathing, thinking, resting, is itself a quiet echo of these quantum rules at work. Every moment, every sensation, every thought built from particles that shimmer in uncertainty, and yet, when gathered together, form the solid comfort of the world around. You float now in the realization that the puzzle was never really a flaw. It was an invitation from the universe to look deeper, to peel back the smooth surface and see the soft luminous weave beneath a fabric stitched from probabilities, from possibilities, from patterns that only reveal themselves when asked. And yet, even here, even in the resolution of this ancient problem, the mystery does not end, for as the old physics bends and reshapes into this strange new form, it becomes clear that quantum mechanics solves one problem, but reveals countless others, questions that ripple out into the future, into mysteries of entanglement, into the paradoxes of superposition, into the strange quiet idea that particles can influence each other instantly across vast distances, as if the universe itself holds hidden threads unseen. And as you breathe slowly, letting this understanding settle, you begin to feel the soft pull toward the next chapter, a place where the answers you have gathered now open gently into even deeper questions about the very nature of reality itself. You float now in the gentle hush that follows understanding, that soft space where answers dissolve, not into certainty, but into wider, deeper questions. Like a ripple that never quite reaches shore, you begin to feel the quiet truth that the universe is not a puzzle to be completed, but a song that never ends. Each answer hums softly, leading to another verse, another note, a rhythm of mysteries unfolding forever. The 125-year-old problem that brought you here, the stubborn glow of heated objects, has dissolved like morning fog under sunlight, not erased but transformed, and in its place stands not a simple solution but an invitation, an open doorway into a reality far more beautiful and strange than anything classical physics ever dared. Imagine the discovery that energy comes in tiny packets, that particles are not little marbles, but clouds of probabilities, that uncertainty is not just a flaw of measurement, but a feature of existence itself. All of this reshapes the very way you breathe, the way you rest, the way you exist, for every atom in your body obeys these rules. Every flicker of thought, every gentle rise and fall of breath is the quiet echo of quantum rhythms. And yet, even here, the universe holds back some of its secrets, because for every breakthrough, like Planck's quanta or Einstein's photons or Heisenberg's uncertainty, 1,000 new questions bloom. How does entanglement truly work? How can particles influence each other across distances faster than light, as though the fabric of space itself holds hidden threads that we cannot yet see? How does the wave function collapse? Does it collapse, or does every possible outcome exist somewhere in the quiet branching of reality? And if the universe itself follows quantum rules, then what does that mean for the cosmos as a whole? Are there worlds where every possibility plays out quietly alongside this one shadow universe, brushing gently against our own unseen, unknowable, yet softly possible? As you drift through these thoughts, you begin to sense that the edges of knowing are not walls, but horizons, places where curiosity stretches forward forever, never reaching an end, only opening further, like a sky that grows wider the longer you look. The birth of quantum physics did not mark the end of confusion, but the beginning of a new kind of wonder, a realization that certainty was never the goal, but rather the gentle practice of listening, of asking, of watching how nature responds. And it is here, floating on this gentle current of thought, that you begin to understand that the universe itself is not a finished thing. It is not a story with an ending, but a living, breathing unfolding, a whisper that stretches from the tiniest flicker of a photon to the widest expanse of galaxies, from the grains of energy in the glow of heated matter to the dark unknown fabric that binds the cosmos together. And as your breath slows, as your body sinks deeper into rest, you carry with You, the quiet comfort of knowing that the search for understanding is itself a beautiful part of being alive, a gentle dance between what is known, what is not, and what may never be fully grasped, and perhaps that is how it is meant to be, a universe. Forever unfinished, forever singing softly just beyond the edge of what you can see, forever waiting patiently for the next curious mind to listen.